Today's lesson is on graphing quadratic inequalities. So the objectives today is to graph and solve quadratic inequalities in 1 and 2 dimensions. So let's get started. Remember back in semester 1 when we talked about graphing inequalities in 1 dimension. For example, I asked you to graph x less than -2 and x greater than or equal to 4. The first step we did was we set up a number line. Now remember, with dealing with inequalities such as these, we have to use open and closed circles. So we use open circles for less than and greater than signs, and closed circles when we have the equal to part underneath. Plotting -2 and 4 on the number line from least to greatest looks like this. And since it's strictly less than -2 in our first inequality, we're going to use an open circle at -2. And the arrow is going to point to the left because it's all values less than -2. At 4, we use a closed circle because of the equal to part, and since it's greater than, we're going to point our arrow to the right, all values greater than 4 on the number line. When we graphed inequalities in 2 dimensions, such as graph y less than -2x plus 1, this is when we had our x and y axis. So instead of using open and closed circles here, we're actually going to use dashed lines and solid lines. So for example, if we were to graph -2x plus 1, we know it starts at +1 on the y-intercept and it has a slope of -2. Since it's strictly less than, we're going to use a dashed line. Now the next step is, remember, we have to shade above or below the line. Now since it's less than, we're going to shade below the line. Now with graphing quadratic inequalities in 2 dimensions, it's a similar process, but we have to follow some certain steps. The very first step is we need to find the vertex of our parabola. So again, remember, we do second trace, minimum or maximum, depending on how the vertex is shaped. The next step is we want to find the x-intercepts. So again, using our graphing calculator, we can press second trace and do our 0 option to find those intercepts where it crosses the x-axis. And then we need to ask ourselves, is it solid or dashed line? And that's going to be based off the inequality that's given. And then, of course, shading above or below the vertex, again, based off the inequality that's given in our example. So here's an example. I want you to graph y greater than x squared minus 2x minus 3. So remember the steps. The first step is we need to find our vertex. So on our graphing calculator, let's go and plug in x squared minus 2x minus 3. Let's press graph. And here's our U-shaped graph. We notice that the vertex is a minimum point here, so let's use our second trace, minimum, enter, and this is where we want our cursor as close as we can to the min point. We want to be left of it, enter, and try to get to the right side of that minimum point, enter. One more time gives us our minimum point. So here we have a minimum point at 1, -4, so that's our vertex. Now let's find the zeros. It looks like it's at -1 and 3, but to find out for sure, let's use our 0 option. Use our 0, get our cursor as close as we can. This is where we go left once, enter, and then twice right, enter, and one more time, giving us a 0 of -1. Let's find the other one. So pressing second trace, 0, get our cursor to the right side. Again, left, enter, and then twice right, enter, and one more time, giving us our 0 of 3. So we have a vertex at 1, -4, and our x-intercepts are -1 and 3. Let's graph this. So on our coordinate plane, we mark the vertex, which is at 1, -4. We have a 0 at 3 and a 0 at -1. Now since it's strictly greater than sign, we're going to use the dash line for our parabola. So sketching our U-shaped graph through those 3 points, as accurately as we can, we get this. And again, since it's greater than, we're going to shade above the vertex point. So above our vertex point of 1, -4 would be actually all values in between the parabola. So this is where our shading occurs. So it's a little different with the diagonal lines, shading above or below. We shade above or below the vertex now. So there's our solutions. When graphing quadratic inequalities in 1 dimension, we have to follow some similar steps. The first step is we need to set the inequality equal to 0. In particular, we're going to get the 0 on the right-hand side. This is going to help us develop our solutions later. The next step is to graph it on the calculator and find these zeros, so using your second trace option. We're going to plot these zeros on the number line, and then we're going to create what's called a sign chart and graph it. The fifth step is to write the solution out. We can do this in inequality or interval notation, your choice. But let's talk about what this sign chart really is, because this is something new for us. For example, if I had x squared minus 4x minus 21 equals 0, and if I wanted to make a sign chart, really it stems from our number line, stems from our zeros. So let's find these zeros. If you notice the factors of negative 21 that add up to negative 4, this is factorable. In fact, it becomes x minus 7 and x plus 3. But remember, our zeros, our solutions to this, are the opposites. So on the number line, we put negative 3 and 7 from least to greatest. Now, when you're creating a sign chart, you're picking values in between these intervals and plugging it into our function. And really what you're seeing is if it's positive or negative. So for example, if I pick a value less than negative 3, like negative 4, and if I were to sub that into my function, for example, subbing it into the factored form, I get negative 4 minus 7, which is negative 11, times a negative 1. The important thing is that it yields a positive value. So for example, any number that we plug in less than negative 3 will in this case yield a positive value. So we put a plus sign. Now picking a value between negative 3 and 7, an easy one to plug in, would be 0. If I plug in 0 for my factored form, I get negative 7 times positive 3. The important thing is that it yields a negative number. So any value between negative 3 and 7 will output a negative number. So we put a minus sign in between that interval. The next thing is let's pick a value greater than 7. So for example, 8. If we were to sub in 8 for our function, we get 8 minus 7, which is 1, times a positive 11. So we get a positive times a positive, which gives me a positive number. So any value greater than 7 will create a positive value, so we put a plus sign above that interval. So this is in fact a sign chart, and what we're going to use is use this sign chart to develop our solutions later. So here we have an example. It says graph x squared minus 4x greater than or equal to negative 3. Remember, the first step is to set it equal to 0. So adding 3 to both sides gives us x squared minus 4x plus 3 greater than or equal to 0. Notice how 0 is on the right hand side. So the second step is to find these zeros. So in our graphing calculator, going to y equals, we're graphing x squared minus 4x plus 3. We press graph. And we can use our second trace option to find these two zeros, but it looks like in fact it's 1 and 3. But let's find them for sure. So we'll get our cursor as close as we can. Left once, enter. Twice right, enter. Looks like it is in fact 1. Let's find the other one. So pressing second trace, finding the other 0, get our cursor as close as we can to that point, press left once, enter, and then it's asking for right bound, so twice right, enter, one more time, there's our value of 3. So this just confirms that our zeros are at 1 and 3. We plot them on our number line from least to greatest, and then remember our fourth step is to make a sign chart and graph. Remember, to make a sign chart, we're picking values between the intervals. So one value right away to pick in less than 1 would be 0. So sub in 0 to our function. If we sub in 0, we get 0 squared minus 4 times 0 plus 3. Well, this gives us an output of positive 3. So any value less than 1 will yield a positive number, so we put a plus sign. Picking a value between 1 and 3, such as 2, if we were to sub that in, we get 2 squared minus 4 times 2 plus 3. So if we simplify this, we get 4 minus 8 plus 3, which gives us a negative 1. So any value between 1 and 3 will always yield a negative output. So let's put a minus sign. Picking a value greater than 3, such as 4 here, if we subbed in 4 for our function, we get 4 squared minus 4 times 4 plus 3. We actually get 16 minus 16 plus 3, which gives me a positive number. So any value greater than 3 will yield a positive output. So we've created our sign chart. Now the next step, remember, is to graph. And remember, to graph, we need to look back on our inequality. Here we have greater than or equal to. So are we going to use closed or open circles? Well, since it's equal to, we're going to use closed circles. Now, what's nice about having the 0 on the right-hand side, you can think of, when is my function greater than 0? When is my function positive? Well, on our sign chart, if you notice, it's all values less than 1 and all values greater than 3. So we point our arrows towards those positive symbols. Now, when we write our solution, we can do it as an inequality or interval notation. If it was an inequality, it'd be x less than or equal to 1 or x greater than or equal to 3. As interval notation, that's all values from negative infinity to 1. We use a bracket, and it's a union of the two sets. So we write it as bracket 3 to infinity for all positive values greater than 3, greater than or equal to 3. So let's try this one more time with our last example. It says graph x squared minus 15 less than 2x. The first step is to set it equals 0. Subtracting 2x to both sides, we get x squared minus 2x minus 15 less than 0. Notice how our 0 is on the right-hand side. The second step is to find these zeros, find these solutions. So to do this, we could use our calculator, or if you notice, it's factorable. In fact, factors of negative 15 that add up to negative 2 are negative 5 and 3. So here's the factored form. But remember, the zeros are the opposites. So our zeros would be negative 3 and positive 5. This is what we plot on our number line. The next step is to make a sign chart and graph. So here we need to pick values less than negative 3, between negative 3 and 5, and greater than 5 to sub in. Picking a value less than negative 3, such as negative 4, if we subbed it into our factored form now, we get negative 4 times 5 and negative 4 plus 3. So if you simplify it, you get negative 9 times negative 1, which yields a positive value. So any value less than negative 3 will give me a positive output. So we put a plus sign above that interval. Now picking a value between negative 3 and 5, easiest one to sub in, is 0. So let's plug that in. If we sub in 0 for our factored form, you'll notice we get negative 5 times 3, which gives me a negative 15. So any value between negative 3 and 5 will yield a negative output. So let's put a minus sign in between that interval. Lastly, let's plug in a number greater than 5, such as 6, into our function. If we plugged it in, we get 6 minus 5 times 6 plus 3. And if you notice here, we'll get 1 times 9, which yields a positive number, so any value greater than 5 gives me a positive output. So we put a plus sign above that interval. So now that we've made our sign chart, we need to graph. Notice how our inequality here is strictly less than, so we're going to use open circles at negative 3 and 5. And since it's strictly less than, we're looking for all negative values, less than 0. Where's my negative symbol on my sign chart? Well, here it's between negative 3 and 5. So this is what my graph would look like. Writing the solution is everything between negative 3 and 5. So writing it as an equality, we could say x greater than negative 3 and x less than 5 to include all values between it. In interval notation, it'd look like this, parenthesis negative 3, comma 5, parenthesis. So this concludes our lesson on graphing quadratic inequalities in 1 and 2 dimensions. Please be ready to practice tomorrow.